In this mini lecture, I want to briefly look at how vector data is actually structured in a GIS, and then talk just a little bit about the basic symbolization of it. These are things that are going to be addressed more thoroughly in the project videos. As we've already talked about, a vector model consists of points, lines, and polygons. These points, lines, and polygons are actually stored in what are referred to as layers of data in a GIS. Before I move on any further, I think it's worth noting that these points, lines, and polygons are all constructed of nodes and vertices and the lines that connect them. And there are rules that guide how these things are going to be connected and how they are going to work in relation to one another. And these rules are referred to as topological rules. And they're things that I will be touching on over the course of the semester a little bit. We're not going to get too bogged down in topology and topological rules, but you should know that this is something that we talk about in GIS and in geospatial data generally. Now, in addition to there being points, lines, and polygons, there are also things that are called feature classes. And feature classes are essentially points, lines, and polygons that then have attribute data that are associated with all of them. So a true vector model in a GIS includes not just points, lines, and polygons, but then the various data that go along with these. And these are all stored in a project's geodatabase. Why would we use a vector model? And this is important to contrast to raster models that we'll use a little bit later in the course. Well, they can be relatively compact and small. They can, however, be a little bit difficult to use. They don't have the same ability to be used over continuous areas as seamlessly as raster data, and so sometimes they can get a little bit messy. But they tend to produce nicer looking maps, and they're definitely sort of the best starting point for understanding GIS data. Now let's talk just a little bit about how this model is organized in ArcGIS Pro. And again, this is something you're going to be diving into in the project itself. And I don't like to do too much project-based stuff in these mini lectures, but here I think it's important. First, to note that there are layers in a GIS. And these layers can be seen on this screen on the left-hand side. The map is shown, and then there are a series of layers that are under this. And this is a series of layers that include ski trail information and also points along ski trails as well. Some of these data then have attributes associated with them. In fact, all of this has attributes associated with them. But I have the attribute data pulled up for what I call the subway stops, which are each of these points along the way. There's not a lot of attribute data here. There's essentially just a couple of columns of data. But this is where you can find these data in a GIS. So first it's a layer. That's the feature class of points, subway stops. And then you can open up the attribute table of that feature class to find out what information is stored in there. All of these data, and this includes not just the subway stops, but also the trails and the other information, are stored in a geodatabase. And here I have the catalog window opened in ArcGIS Pro, where you can see all the data that are stored in the geodatabase that is associated with this particular map. Now, we manage and we create vector data in a bunch of different ways. We can create it as field data, which you now have some experience doing, but we can also do this, in the office space as well. Back in the day, to digitize a map, we had a big digitizing table that was connected to an old-fashioned PC, and you would literally sit at this table and you would click the points that would then be created into lines and polygons on the map. It was a pretty tedious process, I will tell you that. Today, we use something more, this is still used at times, but we are more likely to be using something called heads-up digitizing, where we're actually doing this digitizing on a screen, looking at satellite imagery and creating vector data on top of it. Once we've created the points, lines, and polygons, then we can start adding attributes into them. And this can be done either in the field or it can be done in the office, creating attribute tables that are associated with the information that's been collected, again, as you did in the last project. Then we can start to manage data. We can start to do different things with it. And the first thing that you'll be doing in the project will be called clipping the data, which is one form of a layered approach to data management and data analysis. So we'll talk a little bit more about that in the next project. Once you have created a map and you have all your layers, you have to start symbolizing these points, lines, and polygons using colors, using sizes of lines or of points, or special symbols that you might associate with the points. You can see, looking at a GIS like ArcGIS Pro, that there are a bunch of different ways to symbolize data. We'll be talking more about this later on, but there are things called unique values, or using quantity to symbolize, making proportional sizes of points, for example. There are a bunch of different ways to do this. However, what you need to do, generally speaking, is have a feature class data with attributes and then symbolize one of those attributes. We'll do more on symbols and designs later in the course. In fact, that's a theme that will be carried throughout a large portion of the course. Right now, I just want you to experiment and have a little bit of fun with the symbolizing. I showed you a map a couple of slides ago that I worked on a couple years ago that had to do with ski maps and points along ski trails. And this is the map that I created using those data. It's been highly modified, and I used computer software that is quite different from what you will use in this project. You'll be using this software later on, but you can find all sorts of interesting ways to create maps, to create colors and sizes and lines and points and polygons, though this particular map doesn't have polygons. So have fun with the symbolizing. Don't worry about it too much. We'll figure out how to symbolize things in more design sensitive ways later in the course.